Hello, everyone. Thank you for joining this Adda talk. We call it Tech Adda within the year 82 community. It's a gathering place to gather, talk about stuff, sometimes technical, sometimes non-technical. It's whatever kind of your expertise you have. We've had some really interesting ones. There was somebody's child who had done some work with archaeology and all that stuff. So, but that's different. So anyway, this Tech Adda is going to be about AI. And as I said in one of the blurbs promoting this, that ever since ChatGPT was released to the public in November 2022, there's been a lot of buzz around AI. Anything and everything has been attributed to AI for good and for bad. Like AI will get your jobs, AI will create fake pictures, etc., etc. Lots of bad, lots of good as well. And behind all of these, there are also some buzzwords that are being thrown around, like ChatGPT and LLM and RAG and ML and NLP and so many buzzwords. So, what are these buzzwords? And here to help us drill down into this is Nitin Borwankar, aka Bor. And here's a little bit about Bor that you may not find on his LinkedIn profile. Nitin was a couple of years senior to us, and by us I mean the folks who are here from the 19 who graduated in 1982. He's a couple of years senior to us at IIT Bombay. He was in H5. Actually, Nitin and I were in wings across from each other. And so let's not talk about the multiple gali and other fights that our two wings used to get into. It was fun for those days, but what happens in H5 stays in H5. So after IIT, Nitin got a job working with TIFR in their radio astronomy department, and that took him to the lovely hilltops of Uti. But scenic pastoral hilltops is not what a full-blooded engineer is looking for. And within a couple of years of befriending and unfriending monkeys in Uti, Nitin quit and came to the US, actually to pursue a PhD in math, actually applied math and then pure math. So also, interestingly, while doing his PhD, Nitin also found religion, and he became a full-time resident at an ashram. He used to volunteer there, and he like waking up at 4 a.m. in the morning to cut vegetables, and then hurriedly leave for classes and come back and help out at the ashram once again. Also, interestingly, that's where Nitin found true love. He met his to-be wife through the ashram, and they have a lovely daughter who is just as adventurous and accomplished as a dad. You might have to ask him more about that. Nitin and his wife moved to the Bay Area from LA in 1990. He worked in the database area for a couple of years. Actually, Nat's wife Aruna and Nitin were colleagues at that time. And after a couple of years, 1992, for those of us who remember, that was the internet revolution. That's when World Wide Web became a reality and was at its infancy. And even at that time, Nitin saw the writing on the wall. So he and a colleague quit Sybase, where he was working at that time, and they started a company called onramp.com, which was going to do exactly that, help people get on the internet bandwagon, the on ramp to the internet. And ever since that time, that's like 1994 or so, Nitin has been a consultant, like over 30 years. One accomplish that I want to mention out here, which is kind of relevant, is that he is the author and creator of a very active GitHub open source repository. It's called Learn Data Science. And that provides a set of tutorials, DIY tutorials, to help folks understand and learn how to do machine learning, how to get machine learning expertise. So check that out. So fast forward to a couple of years from that time, come all the way to a couple of years ago with the introduction of ChatGPT. Again, Nitin has seen the writing on the wall, and he educated himself and many others through presentations and publications on in journals like InfoWorld, where he is a repeated author on the current state of AI in LLMs. We are very fortunate to have him here to help us navigate the buzz around AI. And before I hand it over to Nitin, one last thing. Nitin is an avid cricket fan. I think it's hurting him to not be there at that for the India Bangladesh fan. So if somebody can once in a while interject with scores, etc., maybe it will help. Again, Nitin, thank you for making the time to be with us. You can take it away from here.
Okay, just another reminder for people to mute, please. And I will be starting soon. So let's see. So I'm just going to switch straight away to the slide presentation, and I'll talk while I'm going to do the slide presentation. So give me a second while I do that. So while this is supposed to be what's the buzz and all of that, that was my marketing department with Ollie. This is basically what the presentation is going to be. So there's a lot of talk about large language models, aside from ChatGPT and all of that.
Nitin, if you're sharing, we don't see it yet.
You don't see it yet. Okay, hang on. I did start the share screen. And I did start the desktop, so I'm not sure what is going on. Okay, share button. Okay. How about now?
Perfect.
Yeah?
Yes.
Okay. So essentially, the talk is going to assume you were at some point familiar with some very basic math, and it will be a refresher. I promise it will not be painful. And it's just to give you a quick background, but that background you can use whenever people talk about machine learning or about LLMs, because it's something that's common to everything that goes from machine learning all the way to ChatGPT. And then we'll go into, we'll take a quick break after that. And we can, if there's some short questions about that, we'll keep taking breaks for questions. And at one point, and what Ollie forgot to mention, I think, which would be a good intro, is that I also did some stand-up comedy in San Francisco. And somewhere in between, in one of these question breaks, I will perform a small stand-up comedy bit. I will leave you intrigued as to what that is going to be, because people do impressions of other people. I do impressions of inanimate objects. So I'll leave you with that, and I'll start the presentation. So first of all, do I really need to know about AI and LLMs? And my personal experience about a year and a half ago was I wanted to find out what this was all about. I went to a conference, and for the first time, and I've been going to conferences in San Francisco for the last 20 years or so, and for the first time, I was completely stumped because I didn't understand a single word of what they were talking about. And there were, 20, 25-year-old kids all talking this language that I had absolutely no idea. And I came away thinking, oh my God, something major has shifted, because it felt like a discontinuity. And it felt like everything, including, as Ollie mentioned, I've written some tutorials for machine learning. None of that was useful in this new world. Now, everybody doesn't need to know everything like that at that great depth, but I wanted to know, what is it that makes this different? So I did a deep dive on it. And there is certainly a discontinuous thing that has happened. The developments have been going on for a while. I've been tracking some of them all the way back from 10 years, but something shifted in roughly between 20 and 22. There was a rapid acceleration of these language models. They both got bigger and they got very capable. I do remember tracking this and thinking, oh, this is just a toy. And all of a sudden, there was ChatGPT. So what can you do with it? Why do you need to know about it? It's there, as the blurb says, there's a lot of buzz about it, if for no other reason than to just make sense of it, so that when people are talking, you know whether they're trying to pull a fast one on you, or are they really making sense. And you may need it in business. Your management might say, we want to figure out how AI can help us, et cetera, et cetera. So I think it generally helps to have at least a nodding acquaintance with the technology behind this. So that's what the goal is here. And I don't promise that you will absorb every single thing in this particular 1 hour. However, I think they're going to tape it, and if you're interested, it might be useful to go over it again. So I'm going to go and do a rapid background, starting with our physics lab, where we had uh, uh, a bunch of dots, and we used to jiggle the ruler to try to get the best fit line, uh, and going all the way from that to chatting with the machine. And I'm actually going to show you different interactions and the way I use LLMs, both in a professional way and in a personal way. And then we'll just throw it open uh, for question and answers. So going straight into uh, the nitty gritty of it. Uh, so you may remember, so linear regression, the reason I bring up linear regression is because in this very small example in machine learning, all of the
Oh no.
techniques, all of the techniques that are useful are already in this particular uh, process of trying to find the best fit line. When we do it manually, that's not what we do. However, when we do it in an automated fashion, what does end up happening is that we have to use some techniques that actually go all the way behind the scenes in all kinds of machine learning, all the way up to even ChatGPT and other language models. So I'm just going to focus on linear regression. There are other kinds of machine learning models. If you're in the business, you may have seen all of these. Logistic regression is useful for binary yes, no kind of decisions. Decision trees are used for categorizing and especially useful in non-numerical data. Then in marketing and other places, and as a initial way to sort through your data, there are these clustering techniques where you might find similarities, etc. Right now, I'm just going to focus on this particular thing. And as you can see in these two images, intuitively, we know that the second line uh, isn't as good a fit as the first line. And if this were a ruler, you would jiggle it a little bit more. The other thing to notice is that this is a straight line. And so there are only two parameters that define this straight line. This is important because the number of parameters is a big deal. So a line is fully specified if you know the slope and the y-intercept. And with these two pieces of information, if just somebody tells you these two pieces of information, you can go draw this straight line. So the model of a straight line is captured in two parameters, a slope and an intercept. And you'll see the word model again and again. And what a model does literally is it's an imitation of reality. And the more complex things you want to represent in the model, the more degrees of freedom conceptually you need to have. And those are represented by parameters. In a straight line, you have only two parameters, the slope and the y-intercept, because these are the only 2 degrees of freedom available to a straight line. Uh, Now, if you go into higher dimensions, then you would have more parameters. And in fact, in just regular machine learning and in large language models, you have very, very high dimensional spaces, millions and billions of dimensions. These are not possible to visualize. And in fact, people who build these models have managed to build them, but do not fully know how the information is laid out inside this hundreds of billion dimensional space. But the concepts we are using here, number of parameters needed, fully specifying a model, and trying to fit a model to the data, these carry out all the way from linear regression to there. And so one last thing is uh, we are using our own intuitive visual understanding to move this ruler around. but in reality, we are doing some sort of optimization. We just haven't formally put it down on a piece of paper. So for formally understanding this, if you have two variables, then what you get, and I apologize already for all the symbols on this diagram, but you can ignore, after listening to this, you can forget all about it. But I have to put it here so that we get into the picture. So a two-dimensional space creates a parabola or paraboloid. And what we are trying to do is to find a point at the lowest energy. You think of this thing as energy. Actually, it is error, the amount of error in your estimation. And we want to minimize the error. And this behaves like in nature. Nature minimizes energy. So you think of trying to find the minimum energy point, and you make an initial guess, and then you start iterating until you hit a point down here. This process, gradient descent, is common to all such techniques. And this process of starting here, feeding data, doing error correction, all of this is called training your model. And in the process, what we are doing is starting from some wrong points of these two parameters. Mind you, in language models, it's billions. You start off with a billion dimensional vector of wrong guesses. And then over a period of time, by feeding it data and correcting its behavior, you end up with a model that fully captures your straight line, in which case this is one of them is slope, one of them is y-intercept, and then you read this off from here, and that's your model. In the case of large language models, there's gradient descent that goes on with hundreds of billions of parameters. That's why it takes so much GPU. That's why it's so expensive. That's why only very, very large companies can do this. And they end up with what is called a foundation model. So basically, if you remember from our math, if you have a potential function and you take partial derivatives, it points in the direction of the slope. And so in gradient descent, you put a minus sign and you head in the opposite direction because you want to reduce the loss. So these two things are really the most complicated things you need to remember. The straight line with a bunch of points, two parameters, optimizing parameters. So that's the total amount of math you're going to see, and you can forget it if you don't want to remember that. But this is an important part, is that there are, even in machine learning, there are three different kinds of learning. So unsupervised learning is where you just give a bunch of examples and the model extracts patterns. And I'm giving an example with cricket. So if you just sat and watched as a kid a whole bunch of videos of people bowling, and you were good enough to figure out, how do I bowl leg spin? But you would still have to learn that there's a ball, there's your hand, you have to twist your hand, your fingers, there's a pitch, you have to aim for the wicket. All of those things are not being taught to you by anyone. You're just extracting this information from tons of examples. And now that's called unsupervised because there is no one teaching you. But now there is a method called supervised learning where you get a lot of examples in your data. You have lots of labeled, what we call labeled examples, that this is a good example, that's a bad example. And you constructing these data sets, labeled data sets, is a manual effort. Now it can be automated to some extent, but supervised learning will then take it beyond unsupervised learning, and your model will error correct. You saw it heading down the slope, and when you have a bad example, it goes up the slope because the loss increases. And so it learns that you want to head downstream because you keep pushing it downstream, and then you end up at a good model. And there's a third thing called reinforcement learning, where your coach is going to either give you a lollipop or stand behind you with a bat and give you a whack every time you do something wrong. And so you have rewards and you have penalties to your model. So again, it's plus and minus, and you keep correcting even the supervised trained model until it's doing the right thing. So these three things I bring up because when training a large language model, all these three things are involved. So this will come up later. So This is one, and the recurring themes that happen in all kinds of machine learning model is that you're learning a set of parameters. And the parameters are coefficients in a very high dimensional partial differential equation. That's nobody's ever written out. There's no point in that. And then there's an error function that I showed you that we're trying to minimize. And we give large amounts of data as examples. So these three things just keep recurring. And this is the you can go all the way from a linear regression, learning slope and y-intercept from enough data, all the way up to extracting the rules of knowledge from a ton of text without ever being told what grammar is. And the second part, aside from training, is something called inference. So in the case of your straight line, you've got a bunch of dots, but now you want the value of something in between the dots. So you give it a point, you read it off your straight line that you have now, that's your model, and the model generates a prediction or an answer. And of course, you say prediction because that straight line is not exactly fitting your data. It would be a jiggly line if it was fitting the data. But so even your prediction will have a certain amount of error, and then you can estimate that, etc. But it's still a prediction based on a model of reality. And the other thing is that more training data you can give you better generalization. It's better, but not always, because unless the data has more variety, you will not learn anything new and you will spend a lot of computation. So I'm stepping through a whole bunch of things that usually would take more time in class, but hopefully they're easy to understand, and I'll recap at the end of this. And the last big thing between traditional machine learning and neural networks, which is really what all of this language models and so forth are, is that in machine learning, if you wanted to create a model of given a person's income and credit rating and existing debt and the amount they want to borrow, what is a good interest rate? And so you would give a past examples of like 100 of these and to your model. And in this case, notice that there are 4 parameters. So there are 4 parameters. This is a 4-dimensional model. It's a model in a 4-dimensional space, and the loss function, or the thing that you're trying to minimize, is the error between the ideal interest rate and your predicted interest rate. And so you feed this model, and then you get 4 parameters, and then it's like assuming it's a linear model first, and it will be ax1 plus bx2 plus cx3, et cetera, et cetera. The a, b, c, d are the things that you're estimating initially when you're training. When you're doing inference, you've got all of these, and now you're going to plug in an x, and now you're going to get a y. So this is the same thing as the linear regression, and this is traditional machine learning. These things, income, credit rating, etc., you decide ahead of time, and they're called features. And this process of what are the important parts, the attributes of data to model, that's called featureization, and that's an art in itself. So the much better machine learning models have much better featureization because somebody's sat and really figured out what are the intuitive and unintuitive ways to featureize this. And then, but what happens with neural networks? And neural networks essentially are, you think of a graph that is very richly connected. By graph, I mean a network, not a diagram. Very richly connected network. And at each of these, the nodes of this network, there is a little bit of computation capability. And these are modeled in software, and the computational capability is modeled on human neurons, which take a bunch of inputs. If you've seen the diagram of a neuron, a picture of a neuron, there's things called axons and dendrites, and a lot of inputs coming in from all directions. And when the inputs reach a certain level, the neuron fires, and then it goes into the relaxed state, and then it goes up. So there's a nonlinear behavior, and we model that in the software. I'm not going to get more into that. But the important part here I want to mention is that in neural networks, in a richly connected neural network, again, it models things based on parameters. The parameters are how strongly are these neural networks connected, but you never give the features. You just give it an image and say, this is a cat. You give another image and say dog, and you just give it a bunch of these. And the neural network is internally creating a model. It's internally adjusting the parameters. We still don't understand fully how that works, but it works tremendously well. And so there's been tremendous money put into this, and tremendous research that has gone into using these software neural networks for a lot of purposes. I remember the first one I was introduced to it was when I was in graduate school at USC in 1980s, the early 1980s. And being in Los Angeles, we were also close to Caltech, and we had a lot of exchanges with Caltech. Feynman came over and talked once. We went in a bus once to Caltech to listen to a talk by a guy called John Hopfield, who was one of the earliest pioneers in neural networks. And also at that time, I was familiar with a company called Heck Nielsen Neurocomputing, which was in San Diego. And they built models for the Air Force of the profiles of planes, friendly planes and enemy planes. And it was just a maybe 16 by 16 pixels or 32 by 32 pixels, just black and white. But the neural network would quickly recognize what that was. And so that has been continuing to develop to the point where now we can even quote unquote understand speech. This is, I'm just mentioning this. We don't have to get into this. The important thing to understand is deep learning, as opposed to just neural networks. They have just one layer. Deep learning has tens and even hundreds of layers of such networks horizontally connected together in a layer, and then layers stacked one on top of the other. What do these layers do? Each layer, if you get into it, is extracting a different set of features. That's the best thing to understand. Then the most important thing to understand is that these have been applied in vision and speech and language and all of the things that you see behind the scenes. They're using neural networks in your phone, even in early in search. Google has been using various such techniques. Now, the big inflection that affected things all the way to 2022 started with this major breakthrough. It was a paper that was not the name of the paper, but the technology it introduced was called word to vec. What does that mean? It took a bunch of words from a large piece of text and abstracted out a vector space from it. In other words, each word was a vector in this vector space. Now, this was quite revolutionary, partly not just because of the modeling as a vector, but because when two words were similar in meaning or had some relationship, it turned out that they were close together in the vector space. So this was quite revolutionary because it modeled semantics with a vector space, and it mapped semantics to structure. And once that step was taken, a tremendous amount of development could take place, and a tremendous amount of heavy machinery could be brought to bear, mathematical machinery, because vector spaces are well understood, distances in vector spaces are well understood. So I'm going to take, so the distance is proportional to closeness in meaning. And so walk would be close to ran, even button, however, would be close. Berlin would be close to Germany. And this paper was Mikolov et al. 2013. And in December 2023, it won a Test of Time award, which is that it has stood the test of time. And in this language model business, something standing for 10 years is just ridiculously powerful. Everything gets obsolete within 2 years. And things, even since ChatGPT, have gone accelerated very fast. And the most important thing in this vector space was, and they had that in the paper, that they took a vector for king, subtracted the vector for man, added the vector for woman, and ended up with a vector very close to queen. This is really captures why this thing was so mind-boggling, because not only was it capturing the literal dictionary definition of king, but somehow through context, through words around it, it was understanding. I use this word understanding, always imagine that it comes with double quotes around it, because it is, I don't want to imply that there is understanding happening like happens in the human brain. That lots of people use that. I try to be more precise with the language because there's a lot of confusion around thinking of these models as brains. They're models. They're very complex models. They're models of sizes that we have never seen before. and therefore they do very sophisticated things. I think it's a stretch to call it understanding. Therefore, imagine double quotes around the word. But somehow it was quote unquote understanding that king had a lot more attributes than your dictionary definition. And by subtracting and doing this in vector space, you were ending up with something else that was also meaningful. And so all of these formed a consistent set of meanings represented mathematically. And this was the big change. And so, for example, I'm just some pictures here in vector space, and we are just looking at 3 dimensions. This is a 1,000-dimensional space. These kind of concepts would be related. And the way we find similarity is by looking at the cosine between these two vectors. It's literally called cosine similarity. And you don't need a table for a 1,000 dimensional space. Cosine can be calculated by simply taking a dot product of two vectors, which is you multiply each of their x1, y1, x2, y2, add them all up, you get a scalar. You take their magnitude, square root of x1 squared, x2 squared, etc. You multiply them and you get the cosine. If that cosine is close to 1, the theta is almost 0. They are very similar. If it is 0, then they are at right angles and they probably lie in different spaces and have nothing to do with each other. So once you've done this mapping, you can do similarity search based on semantics rather than keywords. And there's another huge thing that LLMs do. So already we are now going from ordinary vector space to spaces of meanings represented mathematically. And so we just going to recap this. It's been very quick and intense. So we started with linear regression, two parameters. These were the features. There was an error function that estimated how badly off your line was. We extrapolated to rich models with billions of parameters. I introduced gradient descent, which is the way to find the best feature vector or the best parameters. The features and parameters are used interchangeably in language models. We use parameters. We talked about unsupervised, supervised, and reinforcement learning. And this is just a set of things to understand all the questions and answers that come up. Neural nets figure out features by themselves. Deep learning uses stacks, and then word to vec maps words to vector. So this is the conceptual foundation. I could have just gone straight to LLMs, but you would be left with the question saying, how does it all work? We're engineers, we want to figure this out. So this is the conceptual foundation. It's not very rigorous, but it's not wrong. And it's at the level where engineers can use this and talk to each other. So now we go straight to 2022 when ChatGPT, which, as I said, is a multi-billion-dollar model, in addition to having a model underneath, you are also able to chat with it. And there is this thing called constitutional AI. It's called ethical AI. It conditions the answers to have certain characteristics. Now, the more important thing here is I go back to unsupervised learning, supervised learning, and reinforcement learning. All three of those are used in creating models like ChatGPT. And I was given 7 questions to answer. And in answering these, we will do that. So the next thing, before I do that, you'll hear the word generative AI. So generative AI, text and text models come under the category of generative AI. It's AI that generates new things that were not fed to it. We are talking about text, but you may have heard of images being created. There are also sound and more recently video, which is much harder, is coming up where you can create 10 and 20-second videos by some prompts. It's not very good, but a lot of this text stuff and images were not very good in the beginning either. But they iterate and they get better. The regular machine learning, where you're given a bunch of data and you draw conclusions, you make differences, you categorize, that's called discriminative AI or machine learning, to differentiate it from generative AI. And generative AI is this world, a brave new world of AI that we are now standing on the threshold of. So the questions, what is an LLM? And so it stands for large language model. Initial quote unquote large was 500 million parameters. Now it's closer to 500 billion. You can think of it as an artificial intelligence software system. I do not call it, it's an artificial intelligence that thinks. It's a software system distributed over a bunch of computers, and quote unquote understand, it can generate and it can manipulate human language. So the best analogy, and I was asked to give an analogy. I said, I'm not going to give an analogy, but this is probably the best working analogy, is that you have this vast library of all possible scanned and digitized books, articles, websites, and you have a super brained librarian who has, importantly, is read and memorized all of this, can use it to answer questions. You go up to a librarian and say, where can I find a book on the work of this Nobel Prize winner? So your librarian is going to tell you about that. It's going to tell you all the wonderful things that's in the book, but the librarian does not understand the physics that is in the book. So please understand this difference between the LLMs versus what they talk about. They don't generally have a deep understanding of the subjects that they talk about. There are lots of efforts going on to teach LLMs math and logic and so forth. I don't understand those efforts because we already have systems that do that, software systems like MATLAB and Mathematica that understand or do very powerful math. Delegating to those makes sense. Some of these have done that. And I think in the future, the language models will form an overview sort of thing, and then the rest of it will be understood, will be delegated to something. By the way, I've missed a mark here. Before starting these questions, I was supposed to ask for questions. So we will take a stop here. And admins, if there are any questions that have come up in the chat, please ask me the questions now.
Yeah, there has been quite a bunch of questions.
Okay, so I'm going to go back. I'm going to scan them quickly.
Okay.
How to identify?
If you want, I can ask the folks to ask them, or I can kind of ask them to make it easier for you.
Yeah, you can pick the ones that you.
So I think one of the questions, I mean, I'm just kind of sorting through what I think is relevant, most relevant. One of them was from Giri Narsiman, who asks, like, when you talk of vectors, actually, Giri, can you rephrase can you say your question? If you can unmute
Sure.
yourself.
Yeah, you talked about how you go from words to these vectors. What if I have a sentence or a paragraph or a document? How do I turn that into a useful vector?
Yeah, I mean, that's a very good question. That's a natural extension of words. And what happens is there are different ways to do this. Surprisingly, what people have done and seems to work. I haven't dug too deep into it because I'm a practitioner. I just use these things. I play around with it, and then when I don't understand something, I go read about it. But the sentence so this process of taking words and creating vectors is called embedding. You're embedding words in a vector space. And similarly, there are sentence embeddings. And what they've done is taken the word vectors of all the words in a sentence and taken the average of that. That's a very naive way of doing a sentence embedding. Of course, if word order changes, sometimes meaning changes. So I'm not quite sure what the next level thing is. It's not simple, but then when you get to very large language models, they do that very well because they look at word vectors, but they also look at the context of a word, uh, a few 10, 20 words away, even longer. And then they build these probability distributions saying if this word is here, what is the probability of another word being 1 word, 2 words, 3 words away? What is the probability of such sentences? They have been trained on data that is, again, unsupervised. They figure out what are good sentences and what are bad sentences based on the structure of a sentence. And so they have an internal model of sentences. It's not as naive as simply creating a single vector. It's a vector of probability distributions, if you will.
But how can you make a vector out of just one word? What are the elements of that vector?
So that's a good question. There are different ways, and the details are in the paper. But essentially, you just don't take a single word. All these embedding models are of a large corpus of words, and you look at sentences, you look at a word, and you look at how many words away are the other words. Eventually, there are methods to give a score to each word and a score to each dimension of the word. It's hard to capture all that, but what you're doing always is words in context. So when this set of vectors is created, it is understood that these set of vectors are from a certain corpus of a text, and those are meaningful only in context. This brings up um, there's a 19th century or 20th 19th century philosopher called Wittgenstein, who initially started by thinking that you had to define the meaning of every word, but then later on came to the conclusion that words are meaningful only in context, in the way words are used in context. So here, this is kind of embodied in here. We don't, initial naive natural language processing used to use dictionaries, dictionary meanings, but what we have here is the meaning of a word in context. So it's there's not a very simple way I can explain to you, but to say that there are certain heuristics and certain algorithms that are used to map a whole bunch of words to a vector space. I know that's an unsatisfactory answer, but that's as good as I can get here.
So a couple of things. One is Neha wanted to know to kind of again repeat what is discriminative AI. But she
Yeah,
also
okay.
has a comment about which you can guys can in the chat. I think is related to what we are just talking about, how to create a vector from words. And she's given some link which might be useful to deep dive separately. But
Yeah,
anyway, discriminative AI.
yeah. So discriminative AI again is everything that is, by default, if you want to think about it, everything that is uh, before generative AI came along. Discriminative AI is you take data, you draw conclusions from it, but you don't generate new data from, or you don't generate new things from that data. You draw conclusions, you draw inferences, you make predictions, but you're not. So if you're given a bunch of text, you're going to do sentiment analysis. You're going to do parts of speech tagging, you're going to look at this named entity recognition, but you're not generating sentences as a part of your effort. When you start generating sentences, then you're in the part of generative AI. If you're given a bunch of images, you recognize objects, but you're not generating new images. So that's the difference.
Thank you.
So Pratmesh had a bunch of questions. One of them was like, is bad data removed? Actually, Pratmesh, why don't you you had 2 or 3 questions out here, so why don't you jump in if you can?
Yeah, Nitin, thanks. I would like to know how to remove bad data, inconsistent data, so that your model is perfect or close to good one.
Well, we'll come to that in a second, but once you have created this very large model, removing data is not a meaningful sentence anymore, because that data doesn't exist anywhere. All you have is a bunch of parameters that have encoded all your data. So you will have to go back, remove your bad data, and then rebuild the model. That's the naive way to do it. In these very large models, people like Anthropic, who are a competitor to OpenAI, and in my opinion, build far superior model. They have started research to actually look inside these models and see how these concepts are clustered, and perhaps try to remove these concepts. But there's no longer any data once you have this model. So that's really the difference.
Second one, just related to word to vector. Do we need to convert all the words to lowercase, or the model will do that, or removing punctuation marks and all that stuff,
Yeah, you
or
do
it
need to
will
do
be
a lot of data cleaning. I don't know if they do that for uppercase, lowercase. You may or may not, but you do have to remove the junk characters and junk words. You try to reduce also a lot of blanks and all of those things.
And then we'll just take
and
one more question before you jump in.
Yeah.
Ganeriwal, you had some question about specific use cases. Do you
Yeah,
want to jump in?
yeah, sure. Thanks, Nitin and Oli. My question is, if there is for example, we are meeting right now,
Yeah.
and we were to prepare minutes of this,
Yes.
and serious minutes where
Yeah.
if there were serious action items. And do you have any suggestion of where one can get started, which LLM to use, and
Yeah.
how to make it better over a period of time, or what could be?
So there are two things. There are two things implicit in your question. One is you're asking, how do I do this, which is extract minutes from recording. The second thing is implicit is that does the LLM get better, etc. So training of these LLMs is not something an initial person should expect to have to do. There are good enough LLMs that do a lot of the simple use cases. And I'll actually demonstrate this transcription and extraction of stuff. These apps already exist. So you can find them. If you want to go a little deeper, you can use one of the models and use them in a developer mode. But these kind of things, and what I had heard was that Microsoft Teams meetings, you can just push a button at the end of your meeting, you will get a transcript with action items, who's were allotted to whom, who said what, etc., etc. So not only do these things exist, they are beginning to get incorporated into applications.
Actually, I was going to cite that myself.
Yeah,
yes,
yeah.
in Microsoft Teams, which we use,
Yeah,
yes, it's already happening.
Yeah.
And I knew Ganeri was going to ask this question because he's in that business.
No, I mean, for going deeper, please feel free to get in touch with me afterwards. I'll put up my LinkedIn.
Yes,
and
sure.
You can pass messages through Ollie, and then we can pick it up.
And we want to do better than what Teams does today. Frankly, it's
No, there are a lot of things that can be done, but
yes,
if you want to build your own language models, and that's a bigger discussion, we can have that.
Sure. Okay, great.
Okay.
Yeah, Nitin, we can move forward, and guys keep asking questions. I'll try to kind of sort them through some kind of relevance, and we can ask at the end.
Yeah, so there are some. So I just want to mention one thing briefly. This could you consider briefly going over this? This is exactly the thing that I was going to do, and then I removed because this then starts getting deeper and deeper. But this is something that is useful for another presentation, and then we can go deeper into these. And I think that will be valuable, but it's very hard to do when we are at an introductory level.
So when do we have another presentation?
Leave it to Ollie, and we will figure something out.
Ollie, are you do we have another presentation?
Not yet, but we'll. I'm happy to do one. We'll figure it out. Okay.
I'm glad to see the enthusiasm. That's good. That's a good start. So thank you.
Okay. So next. So I said, so think of it as a super brain librarian who can have good discussions on all kinds of topics because they've read all these books, but they are not necessarily experts in these topics. So next, what is the training of an LLM? So I told you the mathematical model behind training of an LLM, where you've got a vector that tries to seek out the lowest error rate. But the steps at a human level is the model is fed vast amount of stuff from web and books and everything that's available on the net and more. And you may have heard that LLMs are nothing but, they just predict the next word. Well, that's only partially true. And two caveats. Anybody who's trying to reduce this whole thing to, it's nothing but X, is playing the role of a blind man and the elephant. They are seeing certain truths, but they are the partial truths. It's very hard to reduce all of this to it's nothing but X. So we carry out a small experiment. I say, quick brown fox jumps over the lazy, and you think dog. See, I can read your mind. You say dog. And the reason you do that is because you have read this sentence so many times that your brain has been trained to predict the next word. And this roughly is what is going on with this first step of creating an LLM, which is predicting the next word. It has seen so many things, and it's hard to imagine how many things there are on the internet. And I will give you an example of the kinds of things that we don't think but are available. I mean, literally billions and billions of pages with tons of text. But when I said quick brown fox jumps over the lazy and you thought dog, the example I was going to give was you think dog, but you don't think cat, or you certainly don't think lazy masala dosa. And just to make sure, I was going to say that maybe this is the first time the word lazy masala dosa has ever been used. Just to make sure, I did a Google search, and there was one page for the lazy person's guide to making a masala dosa. Okay, so you can imagine the most improbable sentence, and it's there on the internet somewhere. So you can imagine the most likely sentences, how many examples of those are there. So predicting the next word becomes, so this is done with these very complicated technologies called transformers. And I will come to that. The transformer is in 2017, Google wrote this paper called Attention is All You Need. And attention is the process by which you're not just thinking of words, you're thinking of the whole sentence, maybe the whole paragraph, you're paying attention to. And they use this awkward terminology of attending to, which is a bit ambiguous, but paying attention to not just a word, not just the 2 or 3 words around it, but the whole sentence, the whole paragraph, because sometimes meaning is accumulates over a sentence, meaning accumulates over a paragraph, and is resolved at the end of the paragraph. So these very complicated models have these very large number of parameters because they need to take in all of this complexity, and they build these probability distributions given that if the word fox is here, what is the likelihood that there is a dog later on? But as you expand, fox jumps over, then the likelihood of the next thing being dog goes up because of the context of fox. And it's a naive example, but that's why it's computationally so extremely expensive. And after all of that, you have the ability to predict the next word. It's not very useful. But then what happens is, so that's all unsupervised learning. These are the 3 stages. First one is unsupervised learning. You just feed it text, say, go figure it out. Just tell me whether you can predict the next word or not. Then you have something called fine tuning. And fine tuning is supervised learning. So you take a model and you're going to add some behavior to it. And most practical uses of LLMs involve this fine tuning. Without this tuning, an LLM is a laboratory curiosity. You add fine tuning to create specific behaviors, and typically is chatbots and the ability to follow instructions. And all of these kind of things are called downstream tasks. And without these downstream tasks, LLMs are not useful. Your ChatGPT and Cloud, which I'll show you, they have all been trained on these behaviors, not just a single response, but multi-turn chats, keeping the previous parts in the context. And that brings us to a word context. So all of these chats have a certain context, which is the previous question and answers. And there is a limit to the size of this context. Early LLMs had a context of about 8K, 16K, not letters, but tokens. Tokens are like syllables, but let's think of them as words. So 16K words, which is not much, but then they got better. And what happens is that if you overrun the context, then stuff starts falling off on the other end. And only the last 16K gets taken. So all of this is part of training. And then finally, in the early days, ChatGPT would answer any question you asked it. How do I poison my bad coworker? It'll tell you how to find a good poison somewhere. And then people said, oh, hey, wait, we don't want this to be out there. And so there was actual human feedback to say things that, actually human beings would not like to have information out there about. And this process is called alignment, aligning with human values. And the RLHF is reinforcement learning with human feedback. And so it's actually given, these answers are given to a bunch of human beings and they mark good and bad answers. And then it's trained to say, as a language model, I'm not going to answer that question, blah, blah, blah. Initially, you never saw that. Now they're getting trained with reinforcement learning. So it requires these 3 layers of training before you have something like ChatGPT. So that's the whole training part. And what exactly is GPT? So it came up in a paper, a generative pre-trained transformer, and you can only trust geeks and engineers to take that and put it into a product. Chat GPT, what does that mean to anybody who's never seen this before? Why couldn't they have called it my friend Chatty Fred or something that makes sense to people? But it was called generative pre-trained transformer, which is meaningless unless you say, okay, generative, it can generate new text. Pre-trained, it has a lot of text, and it has induced a model of language from all of this that's given. And the transformer architecture, this is what is a very complicated thing. It processes sequences. I believe me, you don't want to see what it is. It looks like this, and clearly, even if you had an hour, we wouldn't be able to get into this. So these are stacked neural networks. Each of those blocks has got n layers of neural networks, and note the nx on each side, which means that there are n such blocks. So this is beginning to look like the proteins that make up a virus and so forth, and it's a very complicated piece. And this is really what is at the heart of a lot of these, all of these modern language models. So what causes LLMs to give bad answers? So a lot of them have been trained on data from the internet, so which is just misleading and wrong. And in the hurry to put this out, as I said, bad data has gotten into these models. The later models, they're starting to clean up and start over. The latest Chat GPT 4.0 is supposed to have been started from scratch, and training a model from scratch is at that size takes months, and you're running massive stacks of thousands of GPUs for months. And of course, another reason is context overflow, as I mentioned earlier. And if it loses context, then it can give an answer that's just wrong. So how do you solutions are better data, high quality data, instead of taking text, which is unstructured and may have a lot of contradictions, you build a good, like take a textbook on physics rather than just feed it all the popular articles on physics and provide clarity. But most importantly, how do I use them? Use them as assistants who can make mistakes, but do not use them as definitive sources of info. There are cases, and I don't know how much is real and how much is just made up, but there are cases of people going to Chat GPT for medical info and then acting on that info. This is a very bad idea of any kind. Looking at it as a definitive source of info is a very bad idea at this stage. There was another case, again, I don't know if it was just publicity for Chat GPT or not, but there was another case which I think is the right way to do it. Some guy on Reddit talked about how he had this rare disease, doctors couldn't figure it out. He took all his doctor interviews and all his results, and he put them into Chat GPT, and it came up with a list of possibilities, many of which they had already done tests for, but there were a few that they hadn't. And he took it to his doctor, that's what he should have done anyway. Took it to the doctor. The doctor looked and said, "Oh, I'll be darned, I never thought of that." And then they did some tests, and it came out to be that that's what it was. Again, nobody has verified this. I do not know whether this is a publicity stunt, but that's the right way to proceed, was my point, is like, go to the experts, do not give up taking advice from experts. So what is hallucination? You'll hear this word. It's a bad word. Hallucination means, in literal terms, it means that you're on drugs, your brain is not functioning properly, you're coming up with stuff that is meaningless, especially you're babbling and what you're saying makes no sense. So that's not what happens when an LLM hallucinates. What it should be is what I call it supremely confident bullshit. And basically, it will just make up stuff that if you did not bother to verify, will turn out to be completely wrong. In the early days of ChatGPT, I decided to bootstrap myself by asking ChatGPT, what are the best 5 papers I should read to understand large language models? And it was only trained till 2021, September 21. So it gave me some papers, and I said, look, those are from 2019. Can you give me something later? And then it just made up 5 names of papers, authors. The links it gave me did not even resolve. So the reasons can be that you're asking it questions where it's after its training data, but it is trained to generate the most plausible, most possible thing. It doesn't know truth from falsehood. It's only talking about the most probable next word and sentence to generate. So then it just generates this bullshit. And sometimes the way the questions are asked, it doesn't understand the question, because people often are not very good at asking questions. They try to challenge it by asking, what about this? And it'll tell you all the facts about that. It won't tell you as if you're arguing with it. So you have to be very literal, and I'll show you examples. And again, don't use it as a definitive source of anything. So what kind of new security risks are created? Of course, there are a lot of them. There's already, because you can also, there are generative AI for voice. This already been used to get a VP of finance to sign a very large purchase order on a Zoom call. And then, of course, there's misinformation and propaganda. You can take, even before large language models, you had these things where you could take videos, you give it a image of a person, and you can overlay it on some other music video. And then you have things like, Joe Biden singing I don't know, rock song or something. And so those kind of things are very likely. There's a lot of effort going on to make sure that the elections coming up around the world don't have that. But this is an arms race, so to speak. And so data privacy, of course, people forget that when you upload something into ChatGPT, that goes into their model. So you should not put your financial information in there. In the early days, somebody from a Japanese car company took their product plans and uploaded it thinking this is an easy way to write a report. But now the product plans were in ChatGPT. So please understand that these public models do not have data privacy. And it's a very strong reason why in the enterprise, and even personally in great extents, learning how to run your own LLMs, and that's a subject of a different talk. It's a very important thing, and I've written some articles on at InfoWorld. If you just Google InfoWorld and my last name, they will come up, how to run LLMs locally. I have a third one in place right now, submitted, and that's going to get published in the next couple of weeks. And then there's new and innovative ways of fooling humans into thinking that the person at the other end is actually a support person and giving you the password and things like that. So, you just have very powerful models of language. You can do powerful things, fooling other people with words and images. And so applications. So this was another thing, is like, can app developers leverage LLMs to build apps? Yes. The short answer is yes. There are two ways to do this. The LLMs have APIs, so you can build an app on a phone or on your desktop that in the back end calls an LLM. I'll actually demonstrate one to you shortly. And virtual assistants that do a lot of work for you. Translation, of course, is a very straightforward thing that's been around for a while. It's just gotten improved. Sentiment analysis has been around. Recommendations has been around. Research assistance is a really good one. And there are certain LLMs that are better at it than the others. And so I'm going to switch to my transcription app. And I'm going to, okay. So what I'm doing here is, I had some thoughts that I just started speaking. This thing will record your thoughts. I just give some thoughts in a free form fashion about how I could model the process of generating the next word as a path in a very high dimensional space. And if that is the case, then what is the most likely sentence and how that's at a minimum energy. And I'm just freewheeling and I'm just talking out loud and this thing is recording. Well, fine, that's just transcription. So what's the big deal? So let me then say, hang on, I'm covering some of this stuff. So then I can say, break this up into segments. Then I go to the AI part. And when I go to the AI part, I can do many things with this. And I can connect, as I said, the API. Behind this, it goes to GPT, and it does things with it. And I can use GPT, or I prefer to use Cloud, which is a much more sophisticated model as far as language is concerned. And I'm going to say, just summarize this, please. Summarize this transcript. And what this will do then is to take this and quickly start generating a summary. So if you're writing an article, if you're a writer doing fiction, nonfiction, you can just start talking to this and it will start, first of all, transcribing it and then adding this ability to do this. So first of all, summarize. Secondly, this is the more sophisticated part. Identify emotions that are there in this transcript. So throughout the transcript, you express a deep curiosity, contemplation, and pondering. So see that just from these words that I've spoken, it is able to pick up a lot of very sophisticated and nuanced understanding of language. Can find out where it's uncertain and speculation, where it's excitement, and most importantly, it's a rambling stream of consciousness, which is exactly what it is. This conveys a freewheeling exploration of ideas without excessive filtering or editing. The associations follow freely from. So this is the sort of thing that either you can definitely transcribe and then move to analysis. It can improve grammar and punctuation, highlight key points, generate an FAQ, split it into paragraphs, create a mind map. So a lot of very sophisticated things can be done. So yes, there are a lot of apps, and this is the point where I'll take a breather, and I will stop sharing for a minute, and I will do my very quick stand-up comedy piece for all the people who have stuck it out for so long. I'll have to go back to sharing later. Okay. So are you able to see me, or?
You're not,
Yes.
yeah, but you're not pinned. So like, how do we, maybe we can each pin you, because we don't see you full screen. For some, that's probably just my view. So maybe
Yeah.
everyone else is.
No, but I can see you full screen. I can only see me pinned.
Oh God. Okay, it's just my view then. But guys, pin him so that you see full screen for Nitin. Okay, I see you on full screen. So
To
go
everyone.
ahead.
Could the model also translate? Yes, it will translate. Translation has been done for a long time. On the top right view, choose speaker, says Pratim Biswas. Oh, there's a grid on speaker.
We can see you full screen.
Yes, go ahead.
Okay, you can see me full screen?
Yes.
Okay, because this is important. Everybody has to see this. This is a visual. Okay.
Ah.
I too can see you full screen.
Okay, good. So what I'm going to do, as I said, I do impressions of inanimate objects. So I'm going to do an impression of our office copier and printer. Okay. So this is the office copier and printer. This is my prop, which is a piece of paper. And this is my impression of the office copier.
That's funny.
Everybody is muted, so I can't hear.
But
anyway, that's fine.
Guys, you can unmute for this.
Okay.
Yeah, you can unmute for this.
It's okay. So anyway, we'll go back to actual doing demos of how I've used it. And
wait, do you want to take some questions?
Yes, questions. Yes, please.
Also, like time check, like we are at 9:12. We have like 18 minutes officially.
That'll be fine.
Okay, got
some
it.
very simple stuff to get people interested.
So there was one question which I think was something that maybe many people have in their mind. So one was from Anand. He says, like, when you do predict the next word, why don't you we always get the same thing? But I also wanted to ask you in context with your own transcribing thing.
Yeah.
Like you've done this many times. Do you see the same output every time, or do you see different outputs every time you do this thing?
Yes. So that's a good question. So first the word. As far as word prediction is concerned, yes, you will get the same word every time, because given the past, the highest probability word is generated. Having said that, there's a thing that they did not touch upon, is that if you want creative outputs, there are a lot of people who use it as a creative output for generating brainstorming while writing a fiction, nonfiction, etc. So there is a thing called temperature, and temperature is analogous to entropy, and it is a certain randomness that is added to the generation of the next word. So instead of taking the most probable word, it'll pick one out of the most probable 5 words or 3 words. You can set that. And so there'll be a certain variation that you can control. But that is for the end product for sentences. Even for per word, you could increase the temperature and maybe you would get a different word. But again, the assumption is that temperature setting is with the least entropy, and then it will generate the next word with high probability.
Got it.
Now, about your question about transcription,
Yeah.
Yeah. So I suspect that it will come out similar, but not be using exact same words.
Mm. Then Nat had actually, Nat, are you still there? And can you
So I
ask
think
a
Revati had
question?
asked whether it meets my expectations. So as
Great.
far as I'll show you, yes, I
Ah.
mean, I dig very deeply into it, and I've been surprised in many cases, but where I'm not, I know why it's not working. So I would say, yes, it makes my life better in terms of removing a lot of load, mental load for just doing menial word work, cutting, pasting, transcribing sort of thing. But also it makes it more interesting because I'm able to have long conversations, learning new things that I don't know before. So I'll demonstrate some of that. So, okay.
Okay, but you didn't
so
see the
both-
question before. I said,
Oh,
how does it meet your expectation vis-a-vis making cartoons?
oh, yeah. So it's not there yet. It's a good question. I actually want to write a bunch of comics that, I'm too lazy to write and draw the comics. So I'm waiting. Otherwise, I will have to, in my copious spare time, train a model to do that.
Don't forget your stand-up comedy is still outstanding here.
Yes.
But I have a question. One
Yes.
thought is that we have reached the limits of AI.
Yes.
Bigger models, more chips are not going to help because the long pole in the tent or the constraint in AI is availability of data. And we've already consumed we've regurgitated Encyclopedia Britannica, the whole Vedas, Upanishads, all Kishore Kumar songs, everything. We've already consumed all that, right? So there's the incremental improvement in models is going to come only by more data. And so the view is, have we reached the end of productivity of the models?
So, there are a couple of implications in what you said. So I want to parse your question a little bit. We have not necessarily reached the limits of AI. We may have reached the limits of very large language models. So there's a difference. The large language models like ChatGPT and so forth, we may have reached the limit of what they can do for us. But these public monolithic models are not the only kind of language models out there. There is a next wave coming with Microsoft adding AI chips to your PCs. Apple has given out details on how they are going to incorporate AI into your Macs. And the next wave is the personalization of AI, taking your personal data in privacy and analyzing it and bringing direct personal benefits to you without you having to do so much work, the kind of work that I have to do when I go to ChatGPT. Because it's personalized, it sees my patterns, it understands what I do. It can predict, that on Tuesdays I'm going to do this, on Wednesdays I'm going to do that. It can create a sort of a routine for me that improves both my life and my productivity and so forth. So I would say this is the end of the first act of this play, the first wave of AI. The monolithic large models have certainly are not showing much improvement. So we may say that ChatGPT 5 will be underwhelming. But by that time, with a year from now, you'll have a lot of AI on your phones and on your desktops and laptops. So that's a whole new world. AI in the enterprise is just beginning to happen. So it's going to move to the next level.
So Ashwin Kalbag had a question about and I think he asked this question before you had gone into CNN, RN, and etc. So maybe Ashwin can ask this question, but also I wanted to add on to that in terms of what Nat was just saying is, okay, we had CNN, RN, and blah, 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 and now we have GPT, the transformer model.
Yeah.
Maybe there's going to be a new thing that comes in, like, I mean, 2 years from now. So even though we have the same data,
a lot of people think that the transformer model is the end, and people have already started comparing whether we have transformed a model in our brain. And, no, this is not the end. This is just the beginning of serious effort. And things are going to get better in terms of hardware, and the software models are going to get less computationally expensive. And things are getting, this is probably the first point where we have just done brute force AI, and things will get better and better because more sophisticated mathematics can be brought to bear. Right now, there is very little mathematics in all of this. It's computer science. I had a boss once a long time ago who loved this modem technology, and he said it's like driving a horse and buggy at the speed of light. And so we are using uh, AI currently driving computer science like a horse and buggy at the speed of light. Things are going to get better in more sophisticated understanding.
There have been lots of questions about transcribing, transcribing, etc. So Anil, can you jump in and ask a question?
Yeah, Nitin, you know that I make these videos in Hindi.
Yes, yes.
I want to reach out to a wider audience in English, German, Russian, so on. So can I use some software so that I can transcribe, translate, and do dubbing?
Yes, I know some people who do that. Maybe I can put you in touch with them. It is because so here's the other issue with these models is that they have been largely trained on English. They have been trained on some European languages. So the next movement in AI will come when a lot of them are trained in Indian languages. The Chinese are doing a lot of effort to train it on Chinese languages. India is not that great in these efforts. There are some, but a huge amount of benefit can come to India when all Indian languages can be interacted with at the same sophisticated level that we can do with English. And I'll show you an example of a transcribing. Now, yes, so it currently it's a bit of an art, and I can put you in touch with someone who does that, and then we can take it from there.
Excellent. Thank you. Please do.
Okay, we'll take one last question. Okay, go ahead. Who was going there?
No, I was just going to suggest, hadn't somebody posted a video about some Mohammed Rafi song in Kishore Kumar's voice? Isn't that like an example of dubbing? Remember that? A few months ago, somebody had posted. I don't know if it's real, but.
Well, I mean, some of these apps do some of this gimmicky stuff in a closed fashion, so you can't even pull out the transcript of what's happening. So I think more industrial strength transcription and dubbing, I think is around the corner. Some people, some startups, some small companies are probably already doing it.
I was going to ask Pumi to ask questions because there's been a couple of questions from him or her. I'm not sure gender. If you're there, Pummy. Oops.
Yeah, very much there. And
okay.
Yeah, I'm speaking right now. So a couple of linked questions. It seems we are a little far away from the point where we can get deep insights into math. So with the current level of generative AI, where we can use it as proof verifiers, which is what mathematicians would love to have, and maybe even generate proofs for unproven conjectures. Some of them are hundreds of years old. And if we are not there, probably because it's a question, probably because we haven't understood neural networks fully. I mean, I'm trying to just link the two. Is the better understanding of neural networks the thing that is going to get us to that level of insight? Right now, there's no insight in generative AI as well.
So this brings me back to our earlier question that in these specialized domains, which when you're doing math, it is very little language understanding that is required.
Okay.
And math has its own syntax and rules and grammar. So there are actually programs separate from generative AI that are theorem proving programs. And I think that is where the improvement will happen. Adding English language understanding to that effort, I don't think adds that much value.
Okay.
So that's the efforts where I think we may be asking an English professor to do mathematical proofs. So that's kind of the analogy here. The librarian is not ever going to learn the math textbook that he will guide you to.
Okay, so that effort is far away. You're never going to.
It may not be far away. Some of the neural network efforts here might leak over into that area. I
Okay.
would expect that that area will also get a lot of energy from this, but it is not directly related to the LLM effort.
Okay, so what I was guessing was the neural network understanding is the area where we could really focus on to improve insight in math and stuff. Is that right?
I think there is something to be said for combining these two. I don't have any further
Okay,
insight,
okay,
but I'm
okay.
sure there are papers on it. Yeah.
Okay.
Yeah.
All right. Thanks.
Yeah. So I don't know. Can I ask a question? This is Rajesh Goika.
Yeah.
Go
Please
for
Hi,
it.
board. Hi. Hi. Long time. So this is Rajesh Goenka. I was also known as Maru back in IIT. We were in the same year, Hostel 6. My question is, I've been reading. So we've been using ChatGPT a lot. In fact, we are integrating it in our platform and app and all that. So we are doing some development around it also. And as you said, it's a large language model. Logic and reasoning is not its strongest point, though I have seen this get better and better.
Yes.
ChatGPT 4.0 that has come out, the great thing about it is that it takes multimodal inputs, between picture, image, words, and everything. And that's useful because humans work with multimodal inputs, voice, image, and text. But I've been reading that the logic and reasoning is getting better, and ChatGPT 5 that will come out will be very strong on logic and reasoning, which is related to maths, but not pure maths, so to speak. Yeah. You have any insight on that? Because what I'm seeing, this whole thing evolve is from being a useful small-time assistant in writing emails and stuff like that to handling higher and higher executive functions. And when logic and reasoning become reasonably strong in the system, it will not remain just an assistant. It will become more like a manager working under me, doing management or executive tasks. And also this whole combination between large language to logic and reasoning to large action that basically means you can instruct the system to do things for you. A simple example is book me a table at 8 p.m. in London between these restaurants and book me a table for 4 people. So it'll check in all the places where a table for 4 people at 8 p.m. is available and work it out for you. So it has to do several steps, figure out and stuff. So the question is ChatGPT 5 or the evolution that you see happening during this year, where do you think we are going to be?
The two things. One of the things about executive function and so forth, that area is, as a subset of these models, is something called agentic behavior, agents that can be tasked to do things. People are also talking about autonomous agents that will just do stuff without your instruction. It's a little dangerous, I think. And I think autonomous agents there may be some use for it, but not going out and acting on your behalf where there is a possibility of harm. So that's the first comment. Second thing about ChatGPT 5, what it will do, logic understanding, etc. These are all black boxes. So there is a lot of I don't want to give my full. It could go on for an hour about my rant about OpenAI, but there is a lot of hype. There is a lot of blowing up things out of proportion as to what damage AI can do, what great things AI can do, coming out of a single source, and that is OpenAI. And so one has to take that with a bit of sort of damping down of all of the amplitudes of the positives and the negatives. And again, it's not possible to predict because one doesn't even know what ChatGPT 5 is going to do. One thing we can say is that why do we need this to do this for us? Providing phenomenal power in language is valuable. We already have logic engines. We already have math engines. Why are we, what we did not ever have is a computer that understood English language or your natural language. So that is valuable. Reteaching that, all the other stuff, I don't honestly see personally, it's not of interest to me, so I don't dig deeper into that. But agents, things that can do things on your behalf, those are interesting. So I want to separate your questions about logic versus agents.
Okay, fair enough. Yeah, I basically think that, as you go towards, artificial general intelligence, which may still be very far away and which may need quantum computing power to really match humans, but combination of language and logic and reasoning is a very powerful combination.
No,
Suddenly,
I don't disagree, but I would love to have this conversation after everybody else's questions are done. We are coming close, so if there are any questions, we can finish and then we can do the speculative bit, which is worth doing, but it's open-ended. So I want to finish off with the
yeah,
question.
sure. Go ahead.
Yeah, I have a comment or a question. Okay, this
Go
is
for it, Vivek.
we were in H5 together, Nitin. Same
Yes.
year, Alvin.
Yeah.
Yeah, you mentioned about like Microsoft and Apple coming out with some things that will be of daily use. I'm using the full self-driving of Tesla every day.
Yeah.
And it knows my schedule. In morning, I get in the car.
Yes.
It sets the thing to my office.
Yes.
Evening, when I come out of office, it sets my destination to home. Then after that, I go hiking. It takes me hiking. So it's working, and I'm very happy. Even in mountains, like 95% plus nines, it's able to
No,
navigate.
Tesla has got a big AI team. They have always been big on AI, and they are, they were at the leading edge on image recognition, full driving, and all of that. So yeah, Tesla is a good example of practical AI. They have overpromised on a few things, so that's coming back to bite them.
I know robotaxis will. I don't know whether they will be real. We'll have to see. But yeah, I worked time on AI
had a question.
hardware, so I had a chance to work on some of those chips. So yeah.
Oh, great! We should talk. Yeah.
Or I have a question.
Hang on, Madhuri Sawant was waiting.
Oh, yeah, okay.
I have a question. Yeah, Nitin, can I ask?
Yeah, go ahead.
Yeah. See, Nitin, I'm working with in education technology,
Okay.
working with teachers, and they have a lot of issues, and they don't know how to use AI to resolve the issues. For example, understanding of students. Okay, today what is happening is they do not understand what is the level of understanding at the end of the session,
Okay.
and they jump to the next level, and when not even 20% students have understood what has happened in the previous class. So
Yes.
how to do this, because I could not find any solution.
Yes.
Next week I'm going for a training in VGTI. VGTI is arranging a training next week, but I really want to know that beforehand, that what is the solution for teachers. This whole thing I understood is very good, because you are getting lot of information, okay, from the data, but whatever is, the data which you don't have proper data, from that how to draw the conclusion.
So the education area, I think, is going to be very positively and negatively impacted by AI. For the junior levels, it will be very positively impacted. For advanced universities and things, it may be negatively impacted. It's just my opinion. But there are ways, for instance, in one of the examples I'm going to say, one second, Ollie, Is it okay if we go for a little bit more? People who are interested can wait, and I can.
Yes, yes. Let's ask Nat. Nat, how are you with time? Nat, are you muted?
Yeah, good
That
to go. Keep going.
Good
Keep
to go.
going.
Keep going.
Keep,
Okay, good.
yeah.
Okay. So, one of the things that I was going to show is how you can give a very structured a prompt to ChatGPT. You can give a topic and say, please generate 10 multiple choice questions for me. And it will generate multiple choice questions. And you can also tell it, when I give the answers, tell me if the answer is right or wrong. Okay. So I bring that as an example because it is possible in some with some small changes to present this to students, and each student that doesn't understand the subject could potentially say, can you generate a quiz for me, and then it can test their understanding. So these kind of things are very much around the corner. There is a bit of a disconnect between all of the things that are possible with chat gpt and the educational system at the junior levels in places like India, because of the resource non-availability, because of the English language, and so forth. And so that's why I say the next big leap for AI will actually be when we try to create something multilingual, transparently translated between languages. In fact, if I were able to put a classified ad in a regional Telugu newspaper, but that would turn up in whatever local language in all newspapers online, then even the market would grow. The market size would grow because transparently people can translate. Similarly, education can grow. And so there are possibilities of giving, I'll give an example that how to use it to generate training materials and customized. So each individual student can have something customized for them because they don't understand this topic.
Thank you.
Guys, raise your hand if you have a
Yeah.
question. We'll just go for. Okay, no. Raise it on this one on Zoom if you can. Better.
Okay.
But anyway, Ravi, go.
Yeah. So basically, all of this complexity apart,
Yeah.
is it essentially all AI assumes that the future is like the past with different probabilities, maybe? That's a
No.
philosophical question, but
No. When you're saying AI, then we are creating a very broad picture that includes machine learning and
yes.
probability. So the language models in AI can generate, you can ask it to write science fiction if you want, and it will write a view of the future. Again, this is language based. So it doesn't really understand that when it writes science fiction, that what are the physics of these artificial moons and this and that. But we are in a gray area when you say that the future is a continuation of the past. Do you mean on the physical world, or do you mean in our imagination? Because if in our
Both.
imagination, then these language models can help you create new visions of the future by just generating things that sentences that we never thought of. But
Oh,
if you're talking about the physical world, yeah, I mean AI is not going to change physics. AI is not going to change. Even if you train it on financial models, it cannot predict what will happen. It is going to extrapolate from the past, especially with these things called black swan events, where something which is of absolute zero or close to zero probability can still happen, and those are hard to predict. So, but AI, as we talk about today, is language models, and no, they are not limited by the past.
okay. Thank you.
I don't see any hands raised, but is there anyone with any question that still wants to ask?
I have a question. Board is a classic kind of $1 million question, right? When would we have sentient AI? When would AI meet consciousness, right? Which you.
So there are, I'll come at it from two different directions. One is, uh, let's start with intelligence. Uh, there are no objective tests, an absolute objective test for intelligence. So for instance, I have a German Shepherd dog that can be trained to do things that humans cannot do. It's a different kind of intelligence. We tend to think of intelligence in a very linear, numerical fashion because we're engineers. We've been trained to think in certain fashions. But there are kinds of intelligence that other living things have that we don't have. So that's just intelligence. Uh, there's a recent article on BBC. Western philosophers, and there are reasons for that, don't even admit as a group of scientists that animals are conscious, things that we might take for granted in common language. So, what is intelligence? What is thinking? What is consciousness? Uh, from a Western philosophical point of view, uh, those knowledge systems have not had enough time to figure this out. They get lost in words. If in the beginning, OpenAI had a very pragmatic definition of what they considered artificial general intelligence. And they said we define AGI as something that can replace human beings in all economically relevant activities. So basically, they defined AGI as the perfect employee, right? Now, what we call intelligence, what we call consciousness, depends tremendously on our knowledge, on our understanding of ourself as individuals and of humanity. I mean, one question that AI raises certainly is what does it mean to be human if this machine can generate better poetry than I can? Uh, so, uh, but I will switch modes now because along with living in an ashram, I also studied ancient knowledge systems, which were far more sophisticated as far as the internals of the human mind are concerned. Uh, Mind, words, language, consciousness, how do they affect each other? And a physical level of consciousness, which is what humans have. Uh, there are these layers of abstractions that they call tattvas. And the tattvas go all the way up to a level called manas, buddhi, and ahankar. And manas is your mind, buddhi is intelligence, and ahankar is a sense of ego, uh, I-ness. And so it's a matter of debate whether these LLMs have a sense of I-ness. They say I, but what is that I? It's just a bunch of software distributed over computers. Uh, but then, there are knowledge systems in Indian language that go well beyond that. And those states of consciousness can only be accessed through meditation. So, what are we as human beings? Are we only up to the mind? The Cartesians, I call them the Cartesians. The Cartesians believe I think, therefore I am. Uh, and I call the complement Eastern philosophical systems as the Taoists, and that includes all of Eastern philosophies, including Indian philosophies. And so the Taoists believe that there are levels of awareness and consciousness beyond the mind, and once you approach those, it is a different state of being. If you talk about Western consciousness, in contrast, is a very primitive notion of consciousness. And these are the debates that when I look at even somebody who is some of the very great leaders of deep learning and so forth, it's laughable. I mean, I took philosophy courses every semester at IIT. We had a 5-year program, if you remember, and every one of my humanities or other courses was a philosophy course. So I could rightly say to have had a minor in philosophy. And then in addition, I studied these things at a very deep level. So I think what AI and LLMs can do for you today is a very pragmatic question that can be answered. What is AGI is always this thing that is 15 years away. And so, the business about objects in the rear view mirror are closer than you think, and objects in front of you are much farther than you think. So AGI is one of those things. So it's useful, but I run out of things to say because I don't want to tell Western philosophers that they don't know what they're talking about. And AGI, I don't know. It's a good. It's like the point at infinity. It's a good target to have, and it's a good driver for improvement. But along with AI, will humans just keep getting better? Will human keeps getting better at doing things with AI so that AGI is never reached? I don't know. Those are somewhat specific, speculative questions. But hopefully, this was not, too abstract for people.
Very deep. Devin, on a more, so someone wants to speak. Who wants to speak?
Yeah, Ollie, thanks. More one question, something in between the philosophy and AI, what we have. Can we have artificial intelligence replace human beings as far as specialist job like wine testing, tea testing, and very importantly, perfumery? Can it be replaced? Because I have seen GLCs are no match when it comes to human instincts.
Right. So the examples you have given involve the ultimate consumer of what you're talking about is a human being. And even with wine tasting, it is so varied that different experts come out with different evaluations for the same wine. Perfume may be a little bit more somewhat objective, but the ultimate consumer is a human. So yes, it is perhaps possible by training these to say this perfume is better than that perfume, but you're always acting on behalf of a human, and the human is the final arbiter of whether that is good or not. Now, slightly different question is, will they ever be better at doing things like inspecting something for cracks? Even looking at an X-ray and trying to find whether the AI and image models have gotten better at finding issues in X-rays than humans. So these are two different kinds of things, because ultimately that's an objective thing. You're looking at an X-ray. Once the image analyzer points out, look, there's a spot, the human can say, yeah, that spot, you're right, it's correct, I missed it. But with perfume, there is, I don't know, maybe you can keep correcting it, and then it does this exact same thing. But there is a subjective element in both of those. I don't know if it can ever replace that.
I wanted to make a comment if all the questions are done.
Please, go ahead.
Yeah, so I have been reading some books by a neurologist named Oliver Sacks.
Yes.
He died in 2015.
Yes.
But he's a great storyteller. And now all this talk, the dry run that we did and today's talk, now we know the innards of how the training works and what kind of probabilistic models are being built. So the linear regression is now billion dimensional space regression and so on.
Yeah, and
so
it's
Oliver
non-linear.
Sacks,
I don't want to imply that it's linear. It's non-linear, high dimensional.
Okay. So Oliver Sacks, in one of the books, he mentions autism. So he had some cases of autism. So
Yes.
his patients are autistic.
Yes.
And in each one of those cases, some faculty of that individual, that patient it performs phenomenally.
Yes.
So it's like totally outstanding. Somebody can see
2
miles away in the dark. Somebody can remember their childhood photographic memory, for example,
Yes,
and
yes.
do painting. So this looks like this whole AI thing looks like an autistic savant to me, without any feelings. They can't process feelings. They can't feel
Absolutely.
what the content
I
is.
think you've hit the nail on the head, because I also think of it as an idiot savant. It does fantastically on language, just doesn't understand anything else. So yeah, I think you've got the right analogy.
Okay. Thanks. And as everybody else is saying, this has been a wonderful eye-opener. Great talk. Ollie,
So Kumi has his hand raised. So Kumi, let's come to you.
Yeah, so I guess this is what Nat also wanted to do. One of our pals from Hostel 6, he's into the investment space, and he couldn't attend today. So there's a question from him. He's involved in writing Python code to do investment research.
Yeah. Divecha.
Yeah, that's right.
Yeah, I had a conversation with him yesterday. He got in touch with me. So I
Good.
answered his question.
Good.
But please read the question so it will be beneficial to everybody.
Okay, so he's saying he's found major differences between the AIs in terms of how well they can understand what I want and write functional code without too many iterations. I've used ChatGPT, Perplexity, Microsoft Copilot, GitHub Copilot, and Claude, which is what you mentioned. Do any of you have suggestions for, or rather, whether you have any suggestions for what might be the best to use? So far, Claude has been the best at taking a very high-level prompt and writing good code. I'm thinking of doing a playoff, choosing a specific task, and then trying all of them. So
Yeah, so
that's his
I had the
question.
conversation with him. Claude is better not just at code, but at some very sophisticated understanding of language and philosophical concepts. I started off with ChatGPT initially. It had some interesting things, but increasingly ChatGPT has gotten very terse. And at this point, I'm going to take a minute and actually show people my interactions with Claude. And if you're going to start off, all of them, there is a free version. But if you're going to use a paid version, I would recommend Claude above the others. Perplexity is also recommended as a research tool because it is like a search engine, but which also gives you detailed references to everything that it came up with. It gives you a full, answer, and at the end, it gives you references. So for research, it is fantastic. So I use
For any research, Nitin, for any research or in any subject?
Generally anywhere you would go to Google for your initial search.
So any subject.
Yes. So Perplexity is like the other LLMs, except it's a little bit more literal, and it will give you references.
But you would say Claude is still better than Perplexity? Is that right?
Claude is useful for open-ended. I'll just show you so that will make sense. I have open-ended conversations with Claude about philosophical things. Perplexity is not the best for that.
Okay.
But, so if I want to dig deep in a subject, Perplexity will give you a good.
So Nitin, we have to wrap up by 10 o'clock. It's
so give me a few minutes.
We have 10 minutes. We have 10 minutes.
Yeah, so I'm going to share screen and I'm going to go back to my.
Is this named after Claude Shannon?
Maybe. I don't know. I honestly don't know. Okay.
So because he was a guru in these things. Yeah. Okay.
Yeah. So I am going to go here and I'm going to give you examples of my interactions. So first of all, I just asked it for code. And so here's an example of just so that you see what is the code for Neuron, and it just generates code for me. And then it goes line by line and explains what is going to happen in each of those. And this is Python. Okay, so that's pretty straightforward. It's very good at doing this. Then the next one is I asked, what's George Boole influenced by systems of logic? And then it tells me a bunch of things. And then it actually made a mistake. I said, hey, what are you talking about? He said, oh, no, let me correct myself. And then, so then there is another, which I shared earlier, is there's a system of Buddhist logic called Chatushkoti, which has 4 states rather than true, false. It's a true, false. Certain things can be both true and false, and a statement is neither true nor false. And it knows about that. Okay. And so I ask it, could it be said that Chatushkoti is more inclusive in a way to describe reality than Boolean logic? In real life contradict. So this is like, I'm having a philosophical discussion with this. And this is a very well-known or rather well-informed on all kinds of philosophies. And then he comments that you have made a very insightful observation. Indeed, it could be argued that it is blah, 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 blah. And then it says this comparison highlights the value of studying diverse logical traditions, etc., etc., etc. Okay, so now this feels like I'm having a conversation with a very knowledgeable person. Then I asked him, how did Aryabhata contribution to astronomy benefit Copernicus? So then he gets into this and gives me great detail about the heliocentric concept. I learned a number of things, that Aryabhata actually had some heliocentric ideas, but he actually created some mathematical models. He created the first sine tables. His accurate sine tables were crucial. We don't know these things because the model we have is came from Western textbooks, and we have a certain approach, and we don't study these things. And this is all very interesting to me, partly because of my interest in Eastern knowledge systems, but also this is all historical stuff. And then I said, can you expand on his heliocentric model? And so he says, yes, he correctly stated that the Earth rotates on its axis, et cetera, et cetera. So then I asked him, was he the first to formulate this? He said, no, there was a Greek guy. And then I said, aside from just the idea, did he do anything useful? He said, yes, he did a lot of useful things. And then they refer to Vedic and Puranic texts. So I said, what Vedic texts have allegoric references to heliocentrism? So he says Rig Veda mentions the sun, Brahmana mentions the sun as the center, etc., etc. So then he says, additionally, the concept of it's crucial to understand these texts were primarily religious or philosophical and not scientific treatises. So I caught him on that. First of all, I asked him something about Surya Siddhanta and this. And then I said, when did a systematic astronomical study begin? And then he says, it's worth noting that this evolved gradually, etc., but they keep saying it's religious. So then I asked him, is the astronomical observations in Vedic text become less astronomical merely because they were used for religious purposes? Should the scientificness of something be judged based on its validity or by how it is used? So then he says, okay, you raise an excellent point that challenges how we categorize and evaluate ancient knowledge. So now we are having a deep philosophical discussion.
Amazing. This is amazing because, it coincides with the kind of stuff I'm interested in. Exactly what the kind
So Cloud is your guy, okay?
Good. So Nitin, if you don't mind, I might bother you once in a way to find out how to use. Yeah, it'll be amazing. Thank you so much.
Yeah. It's very easy to start using Cloud. And it's, as I can see from Nitin's statement as well, I mean, very soon you're thinking of Claude as, hey, another person rather than this animate thing, this animate paper cruncher.
Yeah, but at the same time, Nitin,
I don't think it's a person, but I find it useful to refer to him as a guy,
Yeah.
But at the same time, Nitin, he uses the word inside.
Yeah.
He uses the word inside, but although he comes very close to looking like they have insight, but it doesn't have insight. It's just
these are just words. He knows how to use the word insight, but he doesn't.
That's the beauty. That's the that's amazing.
Yeah. So he has a very good user interface, but he doesn't have a good backend. So
but that is really. I mean, he's used the word insight.
No. There's just Cloud has a very sophisticated understanding.
Yeah, I agree. I Cloud, and I found it extremely interesting. Something
somebody has to unmute. Mute,
Mute, yeah.
Okay.
Yeah. Cloud.
So then I dug deeper. I said, is it not true then by looking at these ancient developments through decidedly modern scientific glasses, one can downplay some achievements in non-Eurocentric cultures, mainly because they rose in or were couched in a religious context? Because I kept pushing, to find out.
Amazing. This is so good.
Because what I want to know, my underlying thing is, I want to know how these models are trained and do they have a Eurocentric bias, which is explicit or implicit, right?
Yeah.
So with others like the Google AI and with ChatGPT, they give up long time ago. They say, oh, no. Aryabhatta had no influence at all on Copernicus. And then, it's like, okay, fine. Not much I can do over there.
Yeah, but this is so much better. Really so much better.
Yeah. So here your observation is astute, highlights a significant issue about Eurocentrism, about secularization bias, about cultural context, anachronistic judgments. And then he says, your point underscores the need for a more inclusive and culturally sensitive approach to the history of science. This perspective is crucial for a more accurate and comprehensive understanding, etc., etc.
I mean, perfect acting like an intelligent person. Perfect acting. It's like you can't make out the difference whether he really has insight or not.
Yeah. And so, I don't care. After a few minutes of thinking, I said, I don't care. I'm having a great time with these conversations. I'm learning stuff.
But could you ask a question with a deeper level where you can make out that there's no real insight, Nitin?
Well, I mean, sometimes, you can tell it's language. He just says, okay, here is what George Boole said about the topic. And then he gives me an example that has nothing to do with the topic. Okay. So then I call him on it. He said, oh, yeah, you're right. I made a mistake. Okay, so
that's not too bad. Not too bad. Still
yeah,
pretty
no, it's
good.
not bad. It's like 99% there, maybe 95.
Yeah,
you know.
maybe more. Yeah.
Yeah, I mean
So Darshan, I've seen Darshan has his hand up for a long time, but we have only like a
2 minutes.
minute.
Yeah.
So go ahead.
Who has the question?
Darshan.
Hello, this is Darshan.
Yeah, go ahead.
Yeah, hello all. I'm Darshan and I'm Raju Damle's friend from 82's batch. So
Okay,
I have
okay.
some bunch of questions.
Well,
And
we
the
have 2
question
minutes,
is
so pick your
regarding
top question. We have 2 minutes.
Yeah. Yeah. So the question is regarding how can we use AI for making available geo-referenced microscale information on climatic geomorphology, so that we could analyze the results for the spatial and temporal data for the water availability in the river basin. So it
Okay,
is
so
regarding that.
this is a proper machine learning project. If you have results and you publish them in papers, then the language models will help you understand the papers, will help you summarize the papers. But using language, you cannot do geology and morphology and physics. You have to just do engineering there, and the results can probably be made available to a very wide community by putting all these papers together and putting an AI wrapper around it.
So can we actually make use of some neural networks over here so that we could generate some sort of digital elevation models or some
Yes, you
pictorial
can use neural
representations of the sun?
networks. You can use neural networks, very rich neural network image processing models, but I want to identify the difference between them and ChatGPT. This is a language model. That is an image processing model.
What about using some DALI or something for that?
No, short answer, no, that's DALI just generates images that, look good, but they are not very scientific.
Okay, Nitin,
Guys,
why
I'm
cloud?
afraid we have to stop here because Nat has a hard cutoff at 10. Can we take this on one-on-one basis? And
okay.
Not necessarily. I don't have a hard cutoff. It's
oh,
just
okay,
that at some point, right, we can go on for the next 2 hours, right? So we want
okay.
respectful of board's time also,
I
right?
will have, I will have a cutoff soon, but
yeah. Okay, go
what
then.
I can do right now, what I can do right now is, since I'm sharing my screen, I'll go back and I will put my go straight down to the last thing. No, I had I just get in touch with me on LinkedIn, Nitin Borwankar. That's the easiest way to get in touch. If you contact me on WhatsApp, I may not be able to answer because 50 people connecting with me on WhatsApp on each on my own number is going to be hard. Maybe we can do a follow-up. Maybe Ollie, best thing could be to just create a group for Q&A on WhatsApp.
Okay.
And then I can answer questions on that group.
Okay.
And
so
then
I will do that
yeah.
for our 82, and then you can also ask, send your
you make it for your original
group,
Adda, and then I will
add the other people in.
Yeah.
Okay.
That's
Sounds
the
good.
best way to handle a lot of this, because then
Yep.
you don't have to put an end to this. But I just wanted to answer, Madhuri's question. So this is how you can program an LLM, and this is literally things you would type in. You say prompt number 1, this is not there. This is what you're starting from your topic. You put a topic, and you say write 10 multiple choice questions with 1 and 3 answers. Answers should be labeled, etc., 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 etc. And this is a IITB guy called Nivedan Rathi who has a newsletter, and I saw this in his newsletter. So, so this is an example of how students can use this. They can use this to test their own knowledge, or teachers can use this at the end of the session to give these quick tests to see how much students have understood. And in these kind of things, I would recommend that people Google this thing called, Google the words prompt engineering. And in prompt engineering, you'll get a lot of things coming up that will tell you if you wanted it to behave as a writer's assistant, give this prompt. You can say, you can tell it that you are an expert writer, generate a paragraph for me on the topic of this. So you can instruct ChatGPT and other LLMs by role. You can tell them you are playing the role of an interviewer, ask me tough questions on data science. And so engineering these prompts is like programming this LLM in English. So the more you learn how to program this LLM in English in a structured fashion, the better you will get out of it.
Okay.
So,
And is cloud using different kind of a database? Because why it is so sophisticated compared to ChatGPT?
well,
Or their neural network is
yeah, so
different
that's,
for deep
that's a
learning?
good question. I don't know if it is using a different database, but once, as I said, you have that train to predict the next word, you still have two more trainings. So the supervised training on specific topics, and then reinforcement learning of good versus bad, those kind of things are beyond the data, and cloud is obviously doing so much better than
Yeah.
ChatGPT.
So is it a deep learning also? Is it a part of the deep learning?
All of these are deep learning. So all of them are deep learning. You don't get to the language models without deep learning. But that is all in the first step of unsupervised ingestion of very large amounts of data. But the following two levels of training differentiate these two.
Yeah.
What about prompt engineering? So if you want to get into that, how should we start?
Yeah, so just Google those words, prompt engineering. You'll get a lot of responses. A lot of them are, like influencers are producing this, 200 prompts that will change your life and that kind of stuff. But still, there's useful stuff in there.
Anything that you've tried and you can say that is better?
I tried those and I have them somewhere. If again, I can post it on our Q&A thing.
Not a problem.
It's not necessarily something that I recommend. It's the first thing that I found and I thought, oh, this is good. But after you get the picture, after looking at one of those documents, you will get the picture how to structure it. And so it's not profound. It's just a new way of talking to an LLM.
So RAG is prompt engineering on steroid, but that's
No,
the
no,
different
RAG
talk.
is not prompting. So I'm glad you bring that. There is an application called of these, which is really useful, called RAG, Retrieval Augmented Generation. As I said, when you train an LLM, there is a cutoff date of your data, events that happen afterwards, it doesn't know about. Secondly, your private documents, your corporation's documents, your internal design documents, ChatGPT does not know about. So there is a limit to what these public SaaS LLMs can do for you. And so you want to augment them with your own corpus of private PDFs, Word documents, text files, etc. And so there are ways to do it privately by running an LLM, and that's my other talk that Ollie attended. And also the articles that I've written on InfoWorld are about retrieval augmented generation and why it's useful. And what that does is you have a corpus of, say, PDFs. They have all your, research reports, and then you pick an LLM, one of the more sophisticated LLMs that are privately available, and you can run them on your laptop or on a server. And you run, in addition to that, there is something called a vector database. So just like relational databases became the basis of business applications, vector databases are the underlying infrastructure for a lot of generative AI applications, because they are able to ingest unstructured text in a vector format, and they're able to do similarity searches. They're able to work with semantics rather than text matches. So you take this and you combine it with a language model. Your domain model comes from your documents. Language model knows how to speak the language. And when you give a prompt, it takes the prompt and it puts it into the vector database and comes out with 5 to 10, say, useful context things. And then it takes your question again and puts it into the LLM along with this context and with an instruction saying, please answer this question given this context. It's not a context that the model had. It's all coming from your documents. It never goes to train that model, but it answers it in a context, just like you had cut and pasted 10 things into a prompt and said, answer it into this context. So then you get an answer that is more relevant to, so that building RAG applications is another thing, and we can talk about that, but those are what my articles are for. If you want to do that in your organization, etc., you can either read the articles if you've got a programming team, or you can call me and we can work something out if that's what you want to do. But that's really what a useful application of local LLMs is about.
So I was going to make a point. Absolutely. So actually, I work a little bit in the RAG area, and I can hope for Intel is when the dust settles, not everyone needs Chat GPT kind of things, right?
Yeah.
At the end of the day, let's say you're a lawyer firm, you have all these cases for last 25 years. Now, when new lawyer joins, now if this is all embedded into the vector database, now he can ask questions and get his own firm's things, and they don't want to put it in the cloud because
absolutely, and that is a very valid.
You can have an enterprise class server, and then
so that's what I do for consulting is those things.
Wow. Okay. No, so the question there, see, so there is the database lookup part, which a CPU can do. And then the LLM itself can be run on a Gaudi or a NVIDIA, whatever.
Absolutely, yeah. Because if you run the LLM outside, then it's the same thing. Your context all goes into the LLM outside. So you have to run the LLM locally.
Yeah, I know. So my question is, see, often, like I said, there are two parts to a RAG, right? One is the database, the initial embedding, and then of course, when the user asks question, you look up, pick out the relevant vectors, and then feed it to the LLM, right? Now, but then there must be something. So two questions. First thing is, do you now still need a 72 billion llama model, or can you get away with a 13 billion llama model, right? Because now it has only to worry about these vectors you fed it. And then, have you seen any difference in accuracy? Because now
there is no single answer to that. It a lot depends on the complexity. There is a lot of trial and error associated with it. The first thing I would do is to use a bigger model.
But in fact, now there's something called SLM. No, RAG and SLM is what they are hoping.
At least for legal thing, a lot of it also depends on how wide the topics are, how many data, how many documents you have, how much sophisticated reporting. Do you have just yes, no answers? Do you want to sophisticate?
No, the database can be in billions of things, right? True. In the end, as you said, the user prompts ask a question. The first job of database retrieval is actually done on a CPU. And now whatever vectors you get, which are relevant, now they are fed to the GPU.
No, the first job also, depending on what you do, this is vector math. So if you have a GPU, it will go much faster. Again,
sure. But I'm saying in general that database.
So let me answer your question about big versus small. It depends on what your question is asking. If you ask, please generate a 100-page report analyzing XYZ. Please make sure to have an overview. Please make sure you wrap it up with some graphs. Then you're going to need a bigger model. In the smaller model, you're just asking, can you tell me the last 5 times that this happened? And then the small model just has to go look up some things and provide you. So the more sophisticated understanding you want out of your documents, the bigger the model you should have. That's the rule of thumb.
Now, is there a way for ChatGPT to tell it, or LL Llama to tell it that, hey, don't use your knowledge, just use this new data? How do they do that? Is there like a side?
No, that is exactly what that RAG application does. Is it tells you just answer it in the context of this data that I'm giving.
No, I know, but see, the LLM has to now take a vector input. It's not just normally LLM.
No. LLM is just taking ordinary language input because the response from the vector database is text.
Correct. The vectors, yes.
So it doesn't. No, not vectors. Actual text.
Okay.
Okay, so the LLM does not know that you have got this from a vector database. You could have typed it in.
Okay, I thought they feed it vectors because they don't retrain the LLM on the fly. They just say use this data, correct?
Yeah, you get text back from the vector database, and then you put that in your context along with your question.
So isn't it then using all the text you have plus what is already knowledge? So it's not like solely using, as Anil was saying, only using that data.
No, it has to use solely because see, let's say you want. Like
but you are you telling it to solely use
let me clarify. Let me clarify. It will answer the question based on your context for facts and stuff. But what the LLM is bringing to the picture is language understanding. It will understand the nuance of what you're asking to do.
Sure.
It will answer it in the format that you are requesting it. But it will take the facts and other things from the context.
The data is what you feed it. Yes. It is not going to bring up some other lawyer case happened with somewhere else, which is in public domain.
Yeah.
It's going to only answer my firm's lawyer questions or something.
Got it.
Okay, so I'll have to wrap up now.
Yeah. I think it was a great session. I think, we can have another one on RAG or something. And then actually for me, this deep dive into how the semantics, that Google's attention, something that will be another, because that's, I think, is the most fundamental breakthrough they did, word to vec.
Yeah, I mean, look, I'm sort of a practitioner. I'm not a researcher. I can tell you how to use these. I can also
No,
tell
I
you
understand. Yeah.
how to take that paper and put it into Google AI Studio. It will give you an explanation of the paper, etc. But getting into how the theoretical thing works, I would rather look at the code.
No, a very high level, right? Like this attention. Yes, I know about that, and that's how they know
That's
this
fine.
is a
We
dog
can have one on
and
attention.
not a cat, right? Yeah. So
now, one of the things, Nat, if you're still here, I would like to get the video and the audio for this.
Yeah, absolutely. We will. I'll send it to you. I'll put in a Google Doc. It's probably very, very large. I'll put in a Google Doc and give it to you. Yeah.
Okay.
And Harish Acharya wants to edit a little bit to take some of the noise out and add some of these chat to the window.
Yeah.
Harish is a great video editor. So once you have it, I'll send you both the raw and the edited one.
No,
And
the
if
editor is
okay,
fine. If you're removing the
okay, guys. Many thanks. Thank you.
Thanks a lot.
Okay.
Thank you so much.
Session.
Thanks a lot.
Thank you so much.
Thank you, Nat.
Thank you,
Thank
Nitin.
you.
Thanks, Nat.
Thank you.
This was very good. Thank you very much.
Fantastic. Thank you so much, Bo. Really, really appreciate it. Have a wonderful rest of the weekend. Cheers.
Wonderful weekend.
Okay, thank you.
Thank you all. Thanks, Bo.
Thank you.
Thank you, Ollie. Thank you so much, Ollie, for organizing this.
Oh, welcome.
And Harish Acharya and Jayesh for doing.
Absolutely.
Yeah, thanks, guys, for all the organization and constantly pushing me to do this. I was like getting annoyed. Like, man,
yeah, by now
so
you'll hate Ollie by now. But
I was like, Ollie,
buy a drink, we'll all be over.
Do so much work for one talk, but it all turned out good. So it's all good.
Great, fantastic. Thank you.